Question 42. You are testing a scale system that determines shipping rates for a regional web-based auto parts distributor. Due to regulations, shipments cannot exceed 100 pounds. You want to include boundary value analysis as part of your black box test design. How many tests will you need to execute to achieve 100% two-value boundary value analysis? This is the given table. First, let us identify valid boundaries. The valid boundaries are circled. So, here we have identified 8 valid boundaries. Next, let us identify invalid boundaries. Here, we know 0 is lower boundary, and 100 is upper boundary. So invalid boundaries are just below lower boundary, -1, just above upper boundary, 101. Question 43. You are estimating the testing time required for a new project. You have gathered information from 3 experts and they have given you the following numbers in days. Check the table. Using the average numbers from the table above and applying the 3-point estimation technique, what is the estimate? From the table, take average, m equals 55, o equals 30, p equals 75. Now, let us use the PERT formulas to calculate the expected time and standard deviation. Plug in the values of m, o and p. And the expected time value is found as 54.17 days. As well, the standard deviation value is calculated as 7.5 days. So the answer is 54.17 plus or minus 7.5. Question 44. Consider the following test cases that are used to test an accounting system. Check the table. Given this information, what is the proper order in which to execute these test cases? Let us start with test case 5, because it has highest priority as 1, but dependency on test 4. For test 4, priority 3, dependency 2. So, go to test 2 which has priority 3, dependency 1. Move to test 1, it has priority 2, dependency none. It is understood every test depends on it. So, now the execution order will be test 1, test 2, test 4, test 5. And the last one is test 3. Since test 5 is not dependent on it. Question 45. You want to estimate the test effort for the new project using estimation based on ratios. You calculate the test to development effort ratio using average data for both development effort and test effort from 4 historical projects similar to the new one. The table shows this historical data. The estimated development effort for the new project is $800,000. What is your estimate of the test effort in this project? From the table, first, calculate average development effort. It is $900,000. Next, calculate average test effort. It is $90,000. So the average test to development effort ratio is 90,000 divided by 900,000 equal to 0.1. Hence, the estimated test effort equals 0.1 times 800,000, which gives 80,000 as test effort. Question 46. You are testing a user story with 3 acceptance criteria: AC1, AC2 and AC3. AC1 is covered by test case TC1, AC2 by TC2, and AC3 by TC3. The test execution history had 3 test runs on 3 consecutive versions of the software as follows. Tests are repeated once you are informed that all defects found in the test run are corrected and a new version of the software is available. Which of the above tests are executed as regression tests? First, identify confirmation tests. In execution 1, failed test cases are TC1 and TC3. So, tests 4 and 6 must be confirmation tests. In execution 2, failed test cases are TC2 and TC3. So tests 8 and 9 are confirmation tests. Identify regression tests. In execution 1, Past test is TC2. So, test 5 is regression test. In this example, previously passed test are rerun as regression tests to verify the stability of the software after updates or bug fixes. In execution 2, past test is TC1. So the regression test is test 7. The correct answer is B. That is, tests 5 and 7 are regression tests.